Hello students, my name is Monsura Ade Okondeji. I'll be taking you EEC 124. The course title is Electronics 1. On completion of this course, you are expected to be able to 1. Appreciate the use of semiconductor devices in useful electronics application. 2. Learn to build and test simple electronics circuits. 3. Which is the principal goal of this course, is that you are further motivated to learn more about how electronic devices work. So the course outline is as it is updated on your portal. So you can check through your portal to know the course outline. So today we will go straight to our first lesson, which is energy bands in solids. Basically, there are three energy bands, and these bands are valence band, energy gap, and conduction band. In the atomic structure of each and every isolated atom, there are specific energy levels associated with each cell and orbiting electron. The energy level associated with each cell will be different for every element. However, generally, the farther an electron is from the nucleus, the higher is the energy state. And any electron that has left its parent atom has a higher energy state than any electron in the atomic structure. It is worthy of note that only specific energy level exists for electrons in the atomic structure of a single isolated atom. The result is a series of gaps between the allowed energy levels where carriers are not permitted. However, as the atoms of the material are brought closer together to form a crystal lattice structure, there is an interaction between atoms. So this interaction between atoms will produce in the electrons of a particular shell of an atom having slightly different energy levels from the electrons in the same orbit of an adjoining atom. So that is when atoms are closely brought together to form a crystal lattice. This results in an expansion of the fixed discrete energy level of valence electrons to bands, which are the bands we are discussing: valence band, energy gap, and conduction band. In other words, the valence electrons in a specific atom crystal of a particular element can have varying energy levels as long as they fall within the band. It is clear that there is a minimum energy level associated with electrons in the conduction band and maximum energy level of electrons bound to the valence shell of an atom. Between the two is an energy gap, that is the electron in the valence band must overcome to become a free carrier. So before electron in valence band can become a free carrier here, that is before they can go to the conduction band, they must overcome this band gap that we call forbidden gap or energy gap. So this energy band is different from various atoms. So the valence band, as we know from our elementary chemistry, has to do with outermost electron orbitals of an atom. So, and we know that in a free state, the electrons, the outermost shell of electrons are in the valence electron. So we can relate that to this valence band. So before this energy can become free carrier, that is when they come to the conduction band, they must overcome this band gap. The band gap here is the difference in energy between uh, the highest energy state of this valence band electrons and the least occupied conduction band. So it's just like saying the energy of the conduction band, the least minus the highest for the valence band. So the energy difference between the highest occupied energy state of the valence band and the lowest unoccupied state of the conduction band forms our energy gap, also called forbidden gap. So in essence, electrons must be excited here by gaining sufficient energy before they can become free carrier of charge. Now, these energy bands that we've understood will help us to understand how materials are classified as far as our field of study, electronics, is concerned. Basically, materials are three. This one of these three that a material can fall into. The first category being an insulator, the second being semiconductors, which we will concern ourselves more with later in this course, and the third, which are conductors. So for insulators, insulating material, there are the three energy bands present. The three energy bands are present, the first being valence, and the second band gap, or what we call forbidden gap, and the third being conduction band. The valence band and the conduction band are farther apart. The highest state of the valence band and the least unoccupied state of the conduction band are far apart, meaning they have a wide energy gap. Wide energy gap means this will need higher energy electron in this state. In the valence band will need high energy before they can go to conduction band. So it means to make it conduct, it needs much energy for the electron to overcome this. So when we increase temperature by any means, electrons here will need high energy before it can go to the conduction band. So the band gap being wide means electrons, when they leave here to go here, needs high amount of energy. So by increasing the temperature, then electron will go here. So increase in temperature means the resistivity fall, the resistance of this material fall, and the conductivity will now increase. That's why we say this material have negative coefficients of resistance. With increase in temperature, resistance fall and conductivity increase. For semiconductor material, we will notice here that there are all the three energy bands too, the valence, conduction, and the band gap between them. But the band gap here is narrow compared to this of insulators. The band gap is narrow compared to those of insulators, meaning that this also needs energy before the electron in the valence band need energy before they break loose and become free carrier in the conduction band. But the energy they will need is not as much as the one of insulators. So semiconductors too, when they are excited by gaining sufficient energy, they move to conduction band, they need energy too. So by the time they increase in temperature, their temperature increase, their resistance will fall. So they also have negative coefficient of resistance, and we should know that resistance is opposite of conductor. So once the resistance fall, conductance increase. So for them to conduct, while the temperature is increased, then it conducts better at higher temperature. So resistance fall, meaning they also have negative coefficient of resistance. For conductors, the energy gap is completely missing. It has no forbidden gap. The valence band and the conduction band overlap, the two overlap, so electrons there easily can move from here to here, so meaning without excitation they already conduct. So increasing their temperature will only distort the regular movement of electrons, so meaning that if we should increase the temperature will distort. This is analogous to let's say people in a room that have one entrance and one exit. By the time there is danger sign, the people would want to rush to leave through the exit all at the same time. Then this disorderliness will lead to people not easily moving out. But if there is no danger sign and everybody is moving, simply exiting the room one after the other, then it will take them less time analogically to leave the room. So in this case, this material does not need increase in temperature for it to conduct. So if you increase temperature, resistance will increase. Electrons will not flow easily between these two bands. So it will not conduct better. So it means it has positive coefficient of resistance. You increase temperature, then the resistance increase. So summarily, we see that the three material are as we see them here. The valence band, the forbidden band, and conduction bands are present in insulator, and they have negative coefficient of resistance. This means with increase in temperature their resistance fall and the energy gap is large. Semiconductor has all the three bands too, but the energy gap here is narrow, meaning little energy as compared to this one is needed before they start conducting, and they have also negative coefficient of resistance. But for conductors, you have only valence and conduction bands present. The two also overlap as we have said earlier, and there is positive coefficient of resistance. So should we increase the temperature, the resistance increases, meaning that it will not conduct as good as it does at low temperature. So that will be the end of the lecture for today. You can get textbooks to read this up and check your portal for your assignments. Good day.